Welcome, Steve Scarisbrook, and welcome to this, the first of podcasts looking at your CPD. Now, primarily, this is going to be aimed at the ATs, architectural technologists, but it's equally as applicable to surveyors, quantity surveyors, engineers, anybody on site, all looking to do their 35 hours of CPD time, which most of us seem to have to do. So this site is all about looking at your CPD, not telling you what to do, but offering you alternatives and room to maneuver, where you can look at the various subjects that I start to look at and see whether it's applicable for you. So this is really an introductory podcast done in 3 different ways, and I'll go through that in a second. But it's a site that is going to be here for most of the term times. We need a holiday too, so I don't think I'll be doing it over the summer months, although I'll probably put a couple of little sort of ad hoc issues in. But mostly this is going to be term time stuff. There'll also be 2 sites involved. One, the AT site, which is the AT-CPD.co.uk, which is where this podcast and the others will list themselves. And also my scays.co.uk site, which is where a lot of the slides that I'm using will reside. So, sources for the podcast. Well, the first one is going to be a video version of this up on YouTube. And just so that you can listen to it on other mediums like Stitcher as a true podcast or on Google Podcasts, I'm going to speak as though this is an auditory type of podcast and there are no pictures. But there are. If you look at the YouTube version, I'll point and talk about what's on the screen. For those of you who are listening as a true podcast, in your phone, walking the dog, as I often am, then on the screen I've got my picture up in the top right, which is the head and shoulders shot of me talking as a video. In the bottom right, I've got the show notes, and then in the top left, I have got the spreadsheet. The slides that I'm using. Now, I've not got them in play. I've got them in audio, in edit mode, just so you can see what's coming up. And I find this much more useful when people are looking at them. So I've got 3 different feeds coming in: my camera, the show notes, and the slides themselves, all coming in from 3 different sources. I'm using software called OBS, Open Broadcast Software, which is very easy to use. And it gives me the chance to do a recording as a video and also download that video as an audio file as well, which is where most of you will hear it on Stitcher and Google Podcasts. And the video version will go to YouTube. I will offer notes for this in the show notes so you can find out where they are, and I'll give you a link to the show notes at the end. The website, AT. So AT-CPD, it's been around for a while now, and I've been using it to show my students my lectures, past and future and present, and the infill lectures I like to do to add content and substance to any of the lectures that I'm doing. And I put them up on here rather than Moodle. I've had requests from a lot of my old students saying they can't access Moodle anymore, and so would they be able to get hold of them anywhere? So I created this site so they can get them. There's everything you want as far as your CPD is concerned, and I'm adding more all the time. Webinars from different people going up there, a archive of older webinars so you can see just who's doing what. There is my general stuff that I'm talking about, various things, articles, books, anything that I think is worthy of looking at in terms of your CPD. I do a spreadsheet of my books that I'm currently reading, and also a spreadsheet of the podcasts I'm listening to, and also the magazines. They're so important. I get an absolute load come through the post, and most of them are dead free. So the only ones I pay for are Wired magazine, the UK version, and another magazine that is specific to my own interest in genealogy, but that's another thing. The skays.co.uk site is all about my slides, everything, all the playlists, different research ideas and search filters that I've added there so that you can look for my past lectures. Also on this podcast, I'm going to start talking about one particular subject every time I do one. And at the moment, I'm doing them weekly. And as I said, it'll probably be term time as far as the timings of these podcasts are. I'm going to try and get them up on a Monday. And so every Monday during term time, there'll be a podcast in the two different places. So at the end of this little bit about the podcast notes and everything else, I'm going to go into a little lecture. And the one I think I'm going to look at is the weather. It's controversial. It's poignant because of the climate changes going on. So I thought I'd do an introduction to the basis of the weather. And the basis has to be our seasons. So I'll do a short introduction to this and we'll go through it. If you're watching this on YouTube, then I am now going to go into my slides over here and I'll go into the first slide. And really, the weather is all about everything. The life, the sea, the mass of the planet, the planets themselves, our moon, the difference between night and day, and all of these things coming together, not singularly, but as a combined, very complicated algorithmic formula that depends on where you are on the planet, if you're in a city or the open air, everything. It is vastly complicated to try and understand the weather. And even worse when you're trying to think what the hell we are doing to the weather. Yes, I know we understand the basis of the climate that we've got in the increase in temperatures, this crisis of climate, but we don't understand everything because of the knock-on effects that this temperature warming and the carbon and everything else is doing to the planet. We have to be so careful when we try to understand how we're going to solve the problem. I agree that the carbon is probably the biggest root we've got, but we have to be very careful in what we're doing and understanding this cycle of weather changes. But the first thing we have to understand is the seasons. What causes the seasons and why they're so important. I think the first thing we have to understand is a little history. About 4.5 billion years ago, there was the sun and a series of very large gas giants, all juggling for position in the outer reaches of our solar system. What we think is that certain planets started to migrate into the center of the orbits. The two of note is Mercury and Venus. And then we have this planet Earth. But what we think is there was another planet there called Theo. And at this time, I'm going to call the Earth that we know it now as Proto-Earth. What we understand and what we think is that the two came together in a collision. Proto-Earth hit Theo, or the other way around. And the two of them combined with a lot of debris. So Proto-Earth and Theo became the Earth that we now know. And the debris eventually, after a couple of million years, formed the moon. And the moon started to orbit that planet Earth. But three other things also happened. The collision caused a tilt in the orbit. The collision caused a tilt in the planet. The collision also caused a spin. And the collision also caused the planet to go into a specific orbit. Now, what I would do is I'll go on to a slide on the YouTube version, which shows the typical view of the planets. And it shows Earth in this particular one, where Earth is a circular orbit around the sun. Wrong. Every book that I've ever looked at on astronomy or anything to do with the planet shows all the planets in a particular circular orbit. I can only presume that's to make it easy to people understand, but it's damn confusing because the orbit is not circular. It's elliptical. And this elliptical orbit that we have, plus the tilt, plus the way that our Earth spins, gives us the seasons that we now enjoy. So on the YouTube version, I've now flicked onto a new slide. And this is my sketch that I did for some students a long time ago. And I've kept it because it just reminds me of everything. So we have this elliptical orbit, but the sun is not placed in the center of the ellipse. It's on the major axis, but it is slightly to one end of the axis than it is to the other. The shorter distance is called perihelion, and the longer distance on the major axis is the aphelion. So the perihelion is around 91.3 million miles in distance. The aphelion, the longer distance, is 94.4 million miles. Now the Earth is trying to go around this elliptical orbit and try and point in the same direction all the time. The orbit doesn't allow the Earth to point towards the sun as it goes around. As many people think, it doesn't do this. It always points in the same direction, and that is along the major axis of the ellipse. It won't be there in 4 or 5 million years' time. It'll be almost 90 degrees and pointing across the minor axis of the ellipse. But at the moment, it's not there, and it won't be for another 4 or 5 million years. It now points along the major axis and always points in that same direction, no matter where it is in its orbit. So it travels around, and as it comes into the top end of the perihelion, the shorter distance, the Earth is pointing away from the sun. In other words, the northern hemisphere is pointing away from the sun. So we go into winter. And because of this 23.4 degree tilt away from the sun, then we have a problem because the sun can't reach the northern areas. So anything above the Arctic Circle generally goes into what we call the midnight sun. It doesn't get the sun at all. I've been in Finland in Christmas, and it's a fabulous place to be, but it hardly gets any sun, maybe an hour or two every day. Anything north of that, they just don't get the sun at all. So as the Earth moves around the sun, it starts to come into the minor axis area. And for the northern hemisphere, this is our typical March coming out of winter period. But for the southern hemisphere, they are now coming out of their summer and going into their autumn period. And as the sun moves further around to the other end of the major axis, to the aphelion, we now see that we are 94.4 million miles away from the sun. But we're still pointing in the same direction. North, or the northern hemisphere, is now pointing towards the sun. Woohoo! We're now looking at our summer in the northern hemisphere. And as you can see, I'm in the UK, so I'm now in my summer period. But the Australia end of the southern hemisphere is now gone into their winter, simply because they are now pointing away from the sun. And this is what causes the seasons. It's a way that we move around this Earth, this planet, how it moves around the sun, and how it does this simply by following this orbital path, having a spin, and also pointing in the same direction all the time. So we have 4 seasons: winter, summer, spring, and autumn. It will not change, not in our lifetime and not in our immediate million-year lifetimes. It will always be this way. But its effect and how the planet deals with our 4 seasons is the big problem. And in the next lecture, I will go and look at and start to talk about the other areas that affect us, namely the wind and what's called the Coriolis effect. But before we go there, I'm going to mention the one last event that is nothing to do with the orbit of the Earth around the Sun, but the Earth's own little planet that orbits, and that is our moon. Now, if you remember right back at the beginning, I said when proto-Earth hit Theo, there was some debris left over, and this debris, after about a couple of million years, formed what we now know as the moon. The moon's been pretty good to us because it's been there for so long. It won't be. It moves away a couple of inches or a couple of mil every year. So in a couple of million years, we will lose the moon. Now, this is not a good idea because the moon is the stabilizing effect. The Earth, if you look at it without any water on it, is a rocky sort of outpost. And with the moon gone, that stabilizing effect of the mass spinning around us is going to go. But that's a couple of million years to worry about. The present is what we should look at and what the moon does for the present, in that it controls the tides. Earth is a water planet, and we have a lot of the stuff. The moon's mass is enough now to alter the gravitational effect on the water, and it tends to drag this water around the planet. And of course, the tides and this movement of water around the planet is a major effect on our climate, what the weather is. So in future lectures, I'll look at this in more detail, but in the next lecture, on the next podcast, I'll go into a little bit more about some better lectures, some more different alternative stuff, but I'll also look at this Coriolis effect, the wind and its movement on the planet, and a little bit more on the moon. So be good. I hope you've liked this. There's a lot more to come, and I'll see you again. Cheers.